Hi folks, it's Sean from Gasleck. I want to run through and explain to you how the ideal boiler heat exchanger and burner works, and we've got one here removed from a boiler. So first things first, up here we'll have the fan and it'll be passing through the air gas mixture into the top of the burner into here. Below the fan we'll have the gas valve, and then as the fan spins faster it draws more gas through, and that's how we can modulate the amount of gas that's being used, and the boiler PCB does all of that weird and wonderful stuff. So here we have the burner. So as you say, the air gas mixture comes into here, it comes into this top section and then comes out here of the burner plate. And so this will now give it a nice rectangular sort of flame, downward firing into the heat exchanger. And then we double check this little seal here as well to make sure that's all intact. And it is a reusable seal. The Worcester ones aren't on the juniors, but they certainly are on these. So we double check that on the inspection on the boiler service. So that's the burner. Here we have the heat exchanger. So it's actually quite heavy actually. So here we have where the spark electrode was taken out, and on this model here, this will also do the flame rectification. On other models, this blank here will actually be where the flame sensing probe will go in, and that'll wire in separately. But on this model here, it was all combined within the one sensor. And then down to here on the bottom side, we'll actually have the gas valve that just bolts on just underneath the fan. And then we'll have the spark electrode generator just on here on the boiler as well. Well, the one thing I really want to show you guys is actually what it looks like inside the heat exchanger, and why it's really, really important every single year with these boilers and these burners and the heat exchangers, why they must be stripped down. It only takes 60 seconds to get the fan and the burner out, to pass some water through to make sure the heat exchanger is nice and clear, because they do clog up, and I'll show you why. So that is the inside of the heat exchanger, and we can see those little, I'm not sure what you call them, those little circular teethy things that come there, and they catch all of the heat and they transfer it to the water. But what you've got is actually they narrow into like a V shape. Now if your heat exchanger starts getting blocked up with the little bits of carbon deposits from the combustion process, we start getting hot spots within inside the heat exchanger, and then that can cause distortion and the heat exchanger to start warping, and we don't want that. So for the longevity of the heat exchanger, we need to keep it clean. So as then the flame comes down and the condensed water is then produced, it comes out at the bottom here. We can see they're almost touching. So there's not a lot to pass through, and at the bottom here is a big sump, and that's the water that comes in from the pump, and that's it off to the system now. So it's a downward firing boiler. So it'll fire the heat down through the bottom, and it'll come out of the bottom into what we call the sump, which is this last big lump of plastic. Then it'll come up on the front on what we call the flue manifold, and then that will connect into the flue system, and then that will then go outside for its natural dilution into the atmosphere, as they all do. But I just want to quickly show you then, guys, how these ideal heat exchangers, how they work, and why it's so important to keep them clean. Okay then guys, you take care, all the best, goodbye.